This is Jeffrey Cohen, and we're going to talk today about quantum computing platforms, the technology, the providers that are all part of the quantum computing ecosystem. And we're Chicago Quantum, and today is November 6th. So, how do we group them? To start off, we look at hardware, full stack providers, software. Think of them as your platform providers, like your ServiceNow of the quantum business. And then there's consultancies and independent software providers. These are solution providers and system integrators. And so why do we publish this information? We hope that you'll contact us for more information or to solution and consume your own quantum computing platform. So all the data is publicly available. This list is based on our own experience, so it's not a research project as much as it's just who we've worked with. And the hardware vendors that also sell software are only listed once. So there's a lot of providers. These are in alphabetical order, from Alibaba to Alpine Quantum Technologies, all the way down to Rigetti, Toshiba, and Xanadu. So a couple key insights. One is there's different approaches. There's quantum annealers, which are really good at optimization. There's universal or gate-based computers, which in theory can do everything that a quantum computer can do. And then there's simulators, which run as if it was a quantum computer, but on classical hardware. Next is that there's different technologies. There's superconducting qubits. A superconducting qubit is a solid state. It's a Josephson junction or a single flux qubit. Think of it as having a current that goes in two directions and has lots of options. The next one's an ion trap. These are little particles that are ionized by removing an electron, and they sit up in a row, and you can shoot laser beams at them and give them a spin. And based on a spin, based on like a direction, you can use them for a qubit. Then you can also use, maybe a little less popular these days, is photons, neutral atoms, or spin qubits. Different access methods. Most companies would want you to use a public cloud to access their quantum computers. It's probably because they're really hard to operate. They're complex. When they break, they need to be fixed. Only one company that we're aware of ships on-premise hardware, and that's D-Wave Systems out of Canada. The next is that simulators. Again, they're offered by Toshiba or Atos or Fujitsu. They currently offer comparable performance. And a number of companies, including Microsoft and IBM and Xanadu, and Intel offer software that can be run on classical hardware. There's really a bimodal distribution of firms. There's real competition between the Fortune 100 public tech companies, those that have a valuation of 100 billion, let's say to a trillion, and the small venture cap or private firms that are making a lot of investments. We don't think this is sustainable. We think over time the successful small firms will be acquired by the larger firms. And as of now, there's no commercial production workloads. So I want to thank you for listening. This is video 1. Take care.